Welcome to this video on Structural Analysis 2. Today we will cover the derivation of the formula for horizontal thrust in two hinged arches. Consider a two-hinged arch of span L subjected to external loads. The net bending moment middle sex at any section is given by the beam moment μx minus the horizontal thrust moment h times y. For this derivation, we make two key assumptions. First, the strain energy due to axial thrust P and shear force F is negligible. Second, the strain energy due to bending moment is predominant. Let's proceed to the energy formulation. Next, let's express the moment of inertia I as I0 secant theta, where theta is the rib angle and I0 is the moment of inertia at the crown. From geometry, cosine theta equals dx over ds, which gives ds equal to dx secant theta. Now, applying Castigliano's theorem, total strain energy U equals the integral from a to b of middlesex squared ds divided by 2ei. Substituting our bending moment expression gives U equals the integral from a to b of open parentheses μx minus hy close parentheses squared ds divided by 2ei. Since the supports are unyielding, there is no horizontal displacement at the hinges. Therefore, by Castigliano's first theorem, the partial derivative of strain energy U with respect to horizontal thrust h must equal 0. Differentiating the integrand with respect to h gives the integral from a to b of 2 times open parenthesis μ-x minus hy close parenthesis times minus y ds divided by 2 ei, all equal to 0. Simplifying this yields the integral from a to b of open parenthesis minus μ-xy plus hy squared close parenthesis ds divided by ei equal to 0. Separating the terms in our integral, 1 over ei times open parentheses minus integral from a to b of μ-xy ds plus integral from a to b of hy squared ds close parentheses equals 0. Rearranging this gives the integral from a to b of hy squared ds divided by ei equals the integral from a to b of μ-y ds divided by ei. Factoring out h gives our fundamental general expression. H equals the integral from a to b of μ-y ds divided by ei, all divided by the integral from a to b of y squared ds divided by ei. Finally, we substitute I equals I0 secant theta and ds equals dx secant theta into both the numerator and denominator integrals. Notice that secant theta cancels out in both terms, and the modulus of elasticity E and crown moment of inertia I0 are constant, so they cancel out as well. This simplifies our integration limits from along the arch curve to across the horizontal span 0 to L. The final formula for horizontal thrust h is the integral from 0 to L of μ xy dx, divided by the integral from 0 to L of y squared dx. Thank you for watching. We have successfully derived the standard formula for horizontal thrust in a two-hinged arch using the principle of minimum strain energy. Use this fundamental relation for your structural analysis problems, and see you in the next lecture.